This is a standard full functioning mini lathe. Has all the capabilities of a regular lathe. It's just a little bit smaller. In order that the students could use it quickly without error, we have made a number of modifications. One modification was the powered feed for the carriage has been disconnected through the gearbox so that power feed cannot be activated by the students. The second modification that was made is for the traverse movement of the carriage. We have placed a permanent stop right at this location right here. That permanent stop prevents the tool bit from ever crashing into the spinning chuck. Another modification that was made is that the tool bit is adjusted for the proper diameter prior to the students ever machining the part. The feed knob has been removed and replaced with a nut that we can adjust each day prior to starting the exercise. Also, the gibs once again have been locked down. Both the gibs for the regular cross feed as well as the compound rest gibs have been locked down to avoid students moving the tool bit from the preset position. Another modification that has been made, not totally evident in the picture here, is we found with moving the lathe in the back of the pickup truck, setting it up, taking it down, and so forth, the actual motor that runs the lathe had a tendency to jar out of position, and we reinforced that with a couple of shim blocks and have not had a problem with the motor since then. The last modification, a little bit difficult to see, but there's a chip shield. This chip shield prevents the chips coming off of the machining operation from falling down and getting behind the carriage and falling into the gear mechanism which moves the carriage. We found that to be necessary on one of our first builds. This particular tool is a mini machining center. What modifications have been done to it is, number one, the handles that allow the vertical adjustments have been removed after the adjustment was set, avoiding students from readjusting it. The gib screws have been tightened down to lock the vertical pretty much permanently in place. We have put a sticker on it that says "Do not turn." Another modification that was made to the milling machine is that once the milling cutter was set up in the center of the slot of the milling machine vise, the gibs were locked down on the X-axis crossfeed, and also the knob that activates that crossfeed was marked with a "Do not turn" sticker. The milling machine vise was also modified with two slots. One slot, as you can see right here, was cut in the vise jaw. This later holds the axle shaft. The other slot was cut 90 degrees to that, and that allows the milling cutter to come through and cut a slot in the axle shaft without hitting the vise. The next operation will be to drill a hole in the shaft for the arm to attach with a screw, a nut, and a washer. To do that, we use a standard drill press. The drill press itself has not been modified. However, the vise on the drill press has been modified in two ways. There is a slot cut in the fixed jaw of the vise itself, and that is to align and set the height of the axle shaft. There is also a slot cut perpendicular to that in the top of the vise through both jaws, and that is to position and center the arm itself of the catapult. I can demonstrate that by dropping the arm into place. It will drop into position like that when it's tightened, so that the drill will come down and drill in the dead center of the axle shaft, which is a very important thing. See, once again, the drill is a number 27. All drills used in this project, drill sizes, are number 27. Part of the project is to take a washer and to form it into a cup. That requires approximately 6,000 pounds of pressure. In order to do that, we utilized a hydraulic jack and built this frame. Also constructed a die setup where a ball is pressed into a machine cup form device. The hydraulic jack was a 4-ton bottle jack, and we built this frame here, and the frame consisted of some side plates, a top plate, a bottom plate where the jack was fastened to. The jack itself was modified slightly to avoid a student from unscrewing the pressure knob on the jack and backing this out and allowing the fluid to come out. Basically, this device does form, as appropriate, that washer into a cup, which is later used in the project. A standard small shear. It was, however, modified by the addition of this red safety that prevents a student from getting their hand or finger either in from the front in the shear or in from the side where the metal goes on the shear. An additional modification was this bar right here, which when the metal is placed into the shear to be sheared, adjusted for a 90-degree or perpendicular cut. This is a standard 1-ton arbor press. 2 modifications are made. One is the sides of the wide slot are rounded, smoothed off. This prevents scarring during a bending operation. The second modification is the handle was permanently secured in place by a screw and a lock nut. This avoids the handle sliding out of place during the student operating the arbor press. The standard small 18-inch brake, it's steel. A couple of modifications were done to it. First off, it was 18 inches long. We cut it at about 11 or so inches. Second modification was the clamping plate. We welded a couple of bolts to it, drilled some holes. The clamping plate therefore cannot move forward or back, always drops down at the correct distance from the bend line to create a perfect bend on the material that we wish to bend. Next modification, we went ahead and welded a plate to the back of it that has a couple of 3/8 inch pins. Both of these pins are designed to perfectly locate the side plates to be bent, such that the bends have to occur in the correct location, front to back, as you see here. The last modification was we got a couple of clamps, industrial clamps, to make it quick for the students to clamp the material in place. All they have to do is push it in place like that. We did add a stop to each side so that they couldn't over or under bend. They just come up to the stop. You can notice it hits those. Once released, the plates come out. They should be mirror images of each other, as you can see. And if they're set down and held, you'll notice that they're bent exactly at 90 degrees. Become the side plates for the catapult.